Okay, everyone, so what we're going to do is now actually use the first derivative test to tell me where a function is increasing or decreasing algebraically. So instead of looking at a graph, we're going to go through and see how we can solve for that. So the first thing I want to do is I want to find my critical points. So when we say a critical point, we mean find where f prime of x is equal to 0, because we are going to solve the inequality. Where is f prime of x greater than 0, and where is f prime of x less than 0? So, I'll make this a little thicker. So that means f prime ends up being 3x squared minus 20x plus 32. And I'm going to set that equal to 0 to find my critical points. At this point, we're going to factor. So we have 3x and x. And then because I need to get 20, I'm thinking of multiples of 32. So 4 and 8. 3 times 4 would be, 3 times negative 4 would be negative 12. Minus 8 would be negative 20. And so my two critical points are x equals 8/3 and x equals 4. So now at this point, since I'm solving that inequality, I'm going to use a number line to, or a sign chart to figure out where this function is greater than 0 and less than 0. So 8/3 and 4, we have negative infinity, we have positive infinity. And at this point, instead of plugging in test points, we're going to use that curve sketching idea of, since this is a polynomial, I can determine where it is above or below the x-axis. So this is a quadratic, and specifically it's a parabola that opens up. So that means my function will be above the x-axis here and here, below the x-axis here, and that means my function is f of x is increasing from negative infinity to 8/3 and 4 to positive infinity, and that is because f prime of x is greater than 0 on that interval, and f of x is decreasing from 8/3 to 4 because f prime of x is less than 0. So that's the first derivative test. We were able to tell where that function is increasing and decreasing just using the first derivative test. All right.